Welcome to Sundar's lecture. This is lecture number 36, and in this lecture we are going to see design of a mod 6 counter using T flip flop, right. So what are all the topics we have seen in the previous class? See, we have started to design we have started designing synchronous counters, and in synchronous counter in the previous class we have seen how to design mod 5 counter using JK flip flop, right. So what is the step number 1? We need to find what is the first we need to find the number of flip flops needed. How to find the number of flip flops needed? Using this formula, that is 2 power n greater than or equal to capital letter n, where small letter n is number of flip flops and capital letter n is the number of states, right. So that is what we have seen in the previous class. And in step number 2, we have chosen that what is the flip flop we are going to use, and then we need to derive the design table. And the next step is to find the inputs to the flip flops using Karnaugh map simplification. And then step 5, we need to draw the diagram for the each inputs, right. So that is what we have seen in the previous class, right. So now we will see using T flip flop. Maybe we have seen JK flip flop in the previous class. Now we will see T flip flop, right. So first step number 1. So we need to find how many number of flip flops needed, right. So number of flip flops needed, right. So that is the first step. What is the thing we need to get here? 2 power small letter n greater than or equal to capital letter n, right. So now we know how many states we have here. Since it is mod 5 counter, since it is mod 6 counter, we need to count from 0 to 6, 5, right, 0 to 5. So number of counts, that means 0, 1, 2, 3, 4 and then 5. Total number of counts we need to find, number of counts is 6, right. So the point is 2 power n should be greater than or equal to 6, right. So what should be the n now? So you know these kind of stuff. So you need to put n is equal to 3 so that this equation will be satisfied. So n which is equal to 3 now. So now how many number of flip flops we need now? 3 number of flip flops we need. So 3 flip flops needed to design a mod 6 counter, right. So that is the step number 1. What is the step number 2? Step number 2, we need to decide which is the flip flop we need to use. They have given you here itself, we have taken that we are going to use a T flip flop. So I straight away write we are going to use a T flip flop, right. So that is what we are going to use. And what is step number 3? Here this is very important to understand here. Step number 3, right. So step number 3, we need to design the, what is the title we have taken in the previous derived design table, right. So derived design table, we will take the same thing, derived design table. So that is the idea, derived design table. So derived design table. So what we need to do for deriving the design table, what we need to do, the first one, we need to find what is the, how many number of clock pulse we are going to give. Maybe I will write how I have written in the previous time. So this is the clock pulses, right. So when I am giving 0, 1, 2, 3, 4, 5, what is the thing we need to get? What is the present state and what is the next state? That is what we are going to get down here also. So the thing is, I will just write it as a clock pulse now. So this is now clock pulse. So clock pulse number 0, number 1, number 2, that means 3, 4 and then 5. This is what we are going to do, right. So what is the present state now? So we need to go for the present state. So present state, the terminology we use is Q. Maybe we need 3 flip flops, right. So what we need to do now? So we need 3 flip flops. So it is a QC, QB and then QA. This is what we need. And what is the next state? What is the next state we need? So Q C plus, maybe I will use the same color, green color, Q C plus 1, Q B plus 1, and then Q A plus 1, right? That is the next state we need to find, right? So how many flip flops we have now? 3 flip flops, right? So what we need to do now, we need to write flip flops inputs. This is flip flop inputs. So how many flip flops you have here? So 3 number of flip flops. So I will write this as now TC, TB, TA. Only 3 inputs, right? In T flip flop only you have one input, right? So for each flip flop you need one input. In the previous example we have taken JK flip flop, so there are 2 inputs are there. So we would have taken JA, JB, JB, and then KB, JC, and then KC, right? So now here you have only one input, so we can write like this, right? So I will put a tabular column. So what is the first step? We will write it down. If it is 0, 0, 0. If the present state is 0, 0, 0, if I give one clock pulse, it has to go to 0, 0, 1, right? That is the idea. If the present state is 0, 0, 1, then the next state, if I give one clock pulse there, it has to go to 0, 1, 0. That is the next state. If the present state is 0, 1, 0, if I give one clock pulse, it has to go to next state. So 0, 1, 1. And if the present state is 0, 1, 1, if I give one clock pulse, it has to go to 1, 0, 0. If the present state is 1, 0, 0, if I give one clock pulse, it has to go to 1, 0, 1. And if the clock pulse is, if the present state is 1, 0, 1, if I give the next clock pulse, where it should go? It has to go to 0, 0, 0. That is the idea, right? So I have not written here mod 6 counter 0. It has to count, if you give one clock pulse, if the present state is 0, it has to go to 1, and then 2, 3, 4, 5. After completing 5, it has to go to again 0, right? So number of counts 1, 2, 3, 1, 2, 3, 6 counts, right? So this is the general idea we have got in the previous example too. Now we need to find what is the input for flip flop. That means C flip flop. What is the input for C flip flop? If the present state is 0, the next state is also 0, right? So present state 0, next state is also 0. So the T input should be 0. And from 0 to 0, again it will be 0, 0 to 0, 0. Here 0 to 1, right? So 0 to 1 means you need to put 1. Again 1 to 0 means also you need to put 1. So if the state is changing, then obviously you will have a 1. If the state is same, then it is a 0. We know these kind of stuffs already. We have studied these kind of things. So it is 0. So this 0 and this 1 has to be compared 1. Here it is 1. Here it is also 1. So it is 0. Here it is 1. Here it is 0. Right. So it is 0. So here it is 0. Here it is also 0. So it is 0, 0, 0. So it is also 0. And from here to here, 0 to 1 it is changing, right? So it has to 1. It has to be 1. And from here to here it is changing, so 0, here to here again it is changing 1, here to here again it is changing 0, here to here it is changing same, no, I have made a mistake, 1 to 0, right? So it is 1, and here to here it is also changing 1, so from here to here it is also changing 1, so from here to here it is changing 1, so here to here it is changing 1. So this is the idea, right? How I made a mistake here. See, at this point, here it is 1, here it is 1, so 0. Here it is 1, here it is changing, right? So 1 to 0 it is changing. So this should be 1, right? So this should be 1. This should be 1. And from 0 to 0, so it is 0. And from here it is 0 to 0, so it is from here also 0, here also 0. So it is 0, right? So now it is okay. I think everything is correct. So what is the next step? We need to derive the expressions for T input. So I will draw the K-map. Everything you know, I don't need to repeat it again and again. So I will draw the K-map and I will show you. I will just put all these values in the K-map. So there is one change I made. This is also 0, right? So because from 1 to 1, right? So this is 1 to 1. So obviously this will be 0. So that one thing I have just changed here. So now I will just draw the K-map, right? That's all. So what I have done now, I have just written all the values for the K-map. What is the inputs now? These are all the inputs. And what is the output? So output in sense we need to derive the expression for this TA, TB and then TC. So that is what we have just written here. See here, I have just written for TC. So I have just written all this as now outputs for TC, TB and then TA. Now we need to simplify this equation, right? So for 6 and 7 we don't have, right? Since this particular mod 6 counter, we have only 6 number of counts, right? So last two states 6 and then 7, that will be don't care condition. So we need not worry about those two cases. So this is in all the K-map I have just written this as XX. It is not needed, so no problem. So how will you make this now? So how will you group this one simply? So what I can do, I can take this as one group, this as the nether group, right? So for TZ, what I will get it for TZ. So here it is a QZ, and what is the common term in these two? QA and then QC. That is the equation we will get. And for this one, we can group these two alone. That is only pair possibility. So that is the only thing we can do. And here you can see what is the common term. Again, it is QA, but it is QC bar, right? And you can see this is an octet, right? So if I consider these two x's to be 1, so I can make this as now octet, right? Simply I can make it as an octet. So TA, I can make it to 1 now, since it is all the numbers are covered. So now you know all the three equations. So it is very simple now to draw the diagrams, right? So how will you draw the step number 5? Step 5, draw logic diagram, right? Draw the logic diagram. So I will just put all the T flip-flops and then I will show you. So I have just taken the three T flip-flops, and how will you connect these now? So first we will give clock pulses. That is the first thing we need to give. So straight away I can give the clock pulse here. So this clock pulse has to be connected to all the flip-flops, right? So since it is a synchronous sequential circuit, since it is a synchronous sequential circuit, all the clock pulses should be connected to a single point, right? So this is now clock pulse, right? It is negative edge triggered clock pulse. That I don't need to say those kind of things, because we have seen all these kind of things in our previous lectures, right? So now I need to give the inputs now, where I need to give the inputs. So first for TC, I need to put an AND gate, and I have to give it from QC and then QA. Both it will come, right? So we need to put those kind of stuffs here. So first I will draw the AND gate. So this AND gate should be connected to TC. That is the idea. And what should be the input of this AND gate now? What should be the input of this AND gate? These two, that is, this should be from QA and this should be from QC. I am not going to connect. It is very clumsy. If I connect all these kind of things, then it will be clumsy. Just I will write right here. So this has to be connected here. That's all, right? So you just do it by yourself, right? What is the next one? TB. Again, I need an AND gate. Again, I need an AND gate that has to be connected to TB. And what should be the input of those two? What is the input of the AND gate? One is from QA again, and the other one is from QC bar here, right? It has to be connected. And what is the TA? It is straight away 1. So what you can do here, you can just put it as 1. That's all. Right now, how will you take the output? From where you need to take the output? From here. This is one output. This is the second output. And this is the third output. This is QC, QB, QA. Then what will happen now? If I give one clock pulse, considering that this three outputs have 0, 0, 0, if I give one clock pulse, it goes to 0, 0, 1. If I give another clock pulse, it goes to 0, 1, 0. If I give another clock pulse, it will go to 0, 1, 1. If I give another clock pulse, it goes to 1, 0, 0. If I give another clock pulse, it goes to 1, 0, 1. If I give another clock pulse here, it goes to 0, 0, 0 again. and that is how this will work. So this is very simple, right? So we have just designed whatever we have written here, that's all. So whatever we have written here, that will be happening here. You can check it out by yourself, right? It is very simple now. So what we will do now, we will go to another one, that is mod 10 counter, right? So we try to do design the mod 10 counter using T flip flop again, right? So I will just write it down, right? Just I have written here design of synchronous decade counter. Maybe we will call it as a decade counter. That is nothing but mod 10 counter. So I will go step by step, but bit fast now, bit fast. So step number 1. So we need to find flip flops needed. So what is the formula to find flip flops needed? We know, right? 2 power small letter n greater than or equal to capital letter N, and we know that here n capital letter N, which is equal to 10, right? So then obviously 2 power n greater than or equal to 10, so you will get n which is equal to minimum 4. So this is the idea now. So what we need now, we need 4 number of flip flops. That is the idea, right? So step number 2, I will go a bit faster again. Step number 2, we are just going for T flip flop. So we are just taking T flip flop, and we know everything right now. So what we will do now, we have to draw the diagram. That means we need to put the derive table now. We need to derive the design table. So what we need to do for that one? Actually, we have what is mod 10 counter. That is the first thing I need to explain, right? So I have not done that one. So see mod 10 counter, which means what we need to do now, we have to count it from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's all. There are 10 counts now. And after this, it has to count to 0. That is the idea, right? So we need to put 4 input system now, since we have 4 datas, right? So we should not put 0, 0, 0 now. We should put now 0, 0, 0, 0, 4. Since we have 4 number of inputs, right? So sorry, not inputs, 4 number of flip flops. So what we need to do now, we need to put the design table in a manner that we need to write the counts as 0, 0, 0, 0, not 0, 0, 0, right? Since if you put 0, 0, 0, then you will have only 8 number of counts, right? So but here we need 10 number of counts, so we need to put 0, 0, 0, 0, right? So I will just put that in the next page. So that's all. Just I have drawn the table now, design table. So what we need to do now, we for the first instant, we will assume that it is 0, 0, 0, 0. What should be the next one? If I give 1 clock pulse, it has to go to 0, 0, 0, 1, right? So if it is 0, 0, 0, 1 present state, next state should be 0, 0, 1, 0. And if the present state is 0, 0, 1, 0, next state should be 0, 0, 1, 1. If the present state is 0, 0, 1, 1, next state should be 0, 1, 0, 0, right? So if the present state is 0, 1, 0, 0, next state should be 0, 1, 0, 1. What is the present state now? 0, 1, 0, 1. What is the next state? 0, 1, 1, 0. And if the present state is 0, 1, 1, 0, the next state should be 0, 1, 1, 1. And if the present state is 0, 1, 1, 1, and what is the next state? It has to 1, 0, 0, 0. And if the present state is 1, 0, 0, 0, next state should be 0, 0, 0, 1. If the present state is 1, 0, 0, 1, we have came to the last state. The next state, it has to go to 0, 0, 0. And just we have written all these kind of things, right? So now we will write the flip-flop inputs. So how will you write this TD now? So you know, right? So this is 0 and this is also 0. If the both cases are same, what is the thing? 0, 0 means 0. When the present state and next state is changing, then the T input should become 1. And we know those kind of steps, right? So this will be now 0. So from this to this, from 6, you can see that all are 0. Here also all are zeros. So from up to 6, obviously you will have zeros. But here you see from 0 to 1 it is changing. So it has to 1. 1 to 0 it is 0 to 0, 0 to 1 it is changing. 1 to 1 it is not changing. So 0. And here you see 1 to 0 it is changing. So it becomes 1. So what I am going to do now, I will just put all the TC, TB, TA with respect to QC to QC plus 1 and QB to QB plus 1 and QA to QA plus 1. I will just compare these two present and next state and I will put the T inputs with the help of the excitation table, right? So I will put all the values and then I will show you how it looks like, right? That's all. That's all. Just I have written all the T inputs now. Now what we need to do? We need to put 4 variable K map now. Since we have the inputs from QD, QC, QB, QA, 4 inputs and we have 4 number of inputs for each flip flops. So we need to draw 4 K map, 4 variable K map and we need to simplify equation for TD, TC, TB, TA with the help of this input. And for all the other minterms from 10 to 15, it will be X. All the cases TD, TB, TC, TA, everything will be what? X, right? So because we don't need those kind of states here, so we can put XXX and then we need to find the final expression. So I will just draw the K map and I will map all these T inputs values there and then I will show you how to map. Mapping I will show, but all other things putting these values, you know all these kind of stuffs already. We have done it many times, so I will just put all those kind of values in the K map. Right, right. Now you see, I have just drawn the Karnaugh map for every inputs, like TA, TB, TC, and then TD. I have just taken this one from this table, right? So you can just cross verify this. You will get it right. Now I need to cover all the ones. See here, if we want to cover all the ones, it is very simple to do all the tables, all the cells that can be mapped, including this X. Why I put X here? That is also I need to tell. Right? Only we have up to 9, minterm number 9. That means number of counts here is 9, right? But all other terms like this is actually up to 9, 10, 10, 11, 12, 13, 14, 15. And these are all X's. You can see here 10, 11, 13, 14, 10 to 15. It will be X. 10 to 15. It will be X, right? So that you need to clearly understand, right? So what should be now TA? It should be 1. Simply you can put like this, right? So for TB, you can see I need to cover all these ones, right? So obviously what I can do now, I can just put like this, make it as a quad, that is the only possibility. And what is the common term in these two? QD bar is the common term. And what is the common term in these two? QA. So QA, QD bar, that is the idea. And you can see here, I need to cover these two ones. So if I want to cover these two ones, I can make this as now quad. What is the answer? I will get QB, QA. That is the idea, right? So maybe I will write it correctly, QB, QA. And for this one, I need to cover this one as well as this one. What is the possibility? Do you have any quad possibility to cover this one? It is not possible, but you can cover this one with quad, right? So this can be considered to be a quad, so that I can write what is the common term in these two. QD is the common term, I can write. And what is the common term in these two? QA is the common term. That is one term I have just written. But I need to cover this one also, right? So what I can do here, since I can only go for pair, this is a pair now. So what is these two? What is the common term in these two? QZ is the common term. And what is the term here you have? QB, QA. That's all. So I have just find what is the flip-flop inputs values. That means where it should be connected. Now with these equations, I can draw the logic diagram, right? It is very simple, right? You can do it now. So I will just write all the expressions in the next page and I will also draw the T flip-flop, right? So I have just taken the equations and also the T flip-flops, right? So what we will have now, so this is the clock pulse. That means I have taken here it to be negative edge triggered T flip-flop, right? So we can connect this clock pulse at a common place, right? So since it is a synchronous sequential circuit, synchronous synchronous counters, so all the flip-flops will get the clock pulse at the same time, right? So this is the idea, that is what we have seen in the first slide itself, right? So we will see also the asynchronous sequential circuit in the forthcoming classes. There this is not possible. No, all the flip-flops will not get same clock pulse at a time, right? So that is the next thing we will see, that we will see separately. So this is now clock pulse. So now what I need to do, I need to connect TA. This is TA I have taken, right? So what is TA now? So simply I can make this to now 1. I don't need to do anything. 1. And for TB, I need to put an AND gate. Simply I need to put an AND gate. So put an AND gate, and we need to connect this AND gate to TB. And what is the input of this AND gate? That is the idea. What should be the input of this AND gate? That should be QA, that is one input. The another one input should be from QD bar. You can get it from here. I am not drawing everything because it will be clumsy, so I am not drawing everything. You need to connect these kind of stuffs, right? So you can do it by yourself. And for TC, that also we need an AND gate. For TC also we need an AND gate. We need an AND gate, and we need to connect two inputs. One is from QA, one is from QA, and the other is from QB. From here and then from here, you can draw it down. And for TD, see here, for TD I need an OR gate first. So all these kind of things, we have already seen how to draw the logic diagram from the expressions. We know, right? So we know, so don't confuse here. So one OR gate is needed. One OR gate is needed. That is, we need to give here. And this OR gate is supplied by two AND gates because you have two AND terms. So one AND is from here, the other AND is from here. So this AND gate is connected like this now, right? So what should be the input of this AND gate now? This two AND gate, this is two input AND gate, and this is three input AND gate, right? So what will be the input now? This is QA and then QD. What is the input? What should be this input now? QA, QB, QC. Now I will get all this term in QD, right? So where will you get the terms now? From where the output will be taken now? So here at that is one point, and from here we'll get another point, and from here we'll get another point, and from here we'll get another point, right? So this is now QD, right? So this is now QD, QC, QB, QA, right? So I have just drawn like this. Anyhow, we will get output as 0 0 0 0 0 0 0 1, like that. You will get it down. If I give one clock pulse, you will get 0 0 0 0. If I give another clock pulse, it goes to 0 0 0 1. If I give another clock pulse, it goes to 0 0 1 1, and it will continue until 1 0 0 1. And then if I give another clock pulse, it go to 0 0 0 0. That is the idea. So we need to connect all these kind of things. I have not connected here anyhow. So you need to connect all these kind of things, right? So this is how you need to design a synchronous counter, right? For mod 5, mod 6, mod 7, mod 17, 18, whatever it may be, you can draw it for all the things, right? So what are all the topics we have seen in this class? So we have seen two different topics, right? So in this class, we have seen how to design mod 6 counter using T flip-flop. So we have followed the same steps whatever we have done in the previous class for mod 5 counter, and we have just written the number of flip-flops, what is the type of flip-flop, and then we have derived the design table, and then we have also derived the inputs for flip-flop. Finally, we drawn the logic diagram for mod 6 counter, and also we have seen decade counter, that is mod 10 counter. From 0 to 9 it is going to count. For that also step 1, step 2, step 3 we have derived the design table, and then we have also derived the inputs for each flip-flop. We have 4 flip-flops here, since it is a 10 count, we need 4 flip-flops, right? So, and then also we have using the final expressions, we have just drawn the logic diagrams. Thank you.